Hey, hello guys, this is Shubhabroto and welcome back to my channel Circuition. Today I will show you how to make a CCD. CCD stands for Constant Current Driver. In this video, I will show you what is CCD, means Constant Current Driver, its application and how it works. So don't skip the video, watch till the end. Let's get started. If you haven't subscribed my channel yet, then hit the subscribe button to watch more exciting and informative video like this. A very easy solution of a constant current driver is IC LM317. But LM317 is a linear regulator and current carrying capability of it very low, which is up to 1.5 ampere. What if we need a constant current driver of more than 1.5 amps? So for that I have designed this circuit. This circuit can be used to drive LEDs or in any type of circuit where constant current is required, and it also can be used as a short circuit preventer. To build this circuit we will require an operational amplifier which will act as a comparator here. I am using a N-channel MOSFET and a 1 ohm power resistor to control the load current in this circuit. A 10 kilo ohm resistor is connected between MOSFET gate and ground to avoid unwanted switching of the MOSFET. I am also using a potentiometer to set the current limit. For providing a voltage supply to the potentiometer, I have used a linear voltage regulator, that is LM705. For powering up the circuit, I am using a 12 volt adapter, but this circuit will work up to 24 volt. You can connect any test circuit to this output terminal, which is short circuit protected. To set the output current limit of this circuit, I shorted the output terminal. To set the current limit, I have adjusted the potentiometer in such a way that there is 1 volt at the non-inverting terminal of the op-amp. At first, I assume the MOSFET is turned off, so no current is flowing through the MOSFET, and the voltage across the 1 ohm resistor is 0 volt. So the voltage at the inverting terminal of the op-amp is also 0. In this situation, the output of the op-amp is high, that means 12 volt. As the output of the op-amp is connected to gate of the MOSFET, so the MOSFET will turn on and the current will start to flow through the MOSFET and the 1 ohm resistor. When the amount of current flowing through the circuit is 1 amp, the voltage drop across the 1 ohm resistor is 1 volt. So the voltage at the inverting terminal will be also 1 volt. As a result, the output of the op-amp will be 0 and it will turn off the MOSFET and stop the current flow. Now we are back at the first situation again. So the same event of turning on the MOSFET will happen, which will create a continuous loop of turning on and off the MOSFET such a way so that the current flow through the MOSFET never exceeds 1 ampere. By adjusting the voltage from 0 to 5 volt at the non-inverting terminal of the op-amp, we can control or limit the current from 0 to 5 ampere. The current limiting range can be increased by increasing the power rating of the 1 ohm resistor and by replacing the 7805 with some other voltage regulator which can deliver more than 5 volt, like 7812 or 7815 can be used. So guys, this is the total circuit setup. I know the appearance of this circuit is little bit clumsy, but here is the op-amp. I am using LM358 and here is the N-channel MOSFET IRF Z44N, and this is 7805 supplying the trimmer pot, and here is the power resistor of 1 ohm 10 watt. Actually I am using 10 watt, you can use 5 watt or 10 watt, anything. And here is the 10 kilo ohm resistor connected to the gate and ground of the MOSFET, and these two terminals are the output terminals which is short circuit protected. You can see in the multimeter the current flowing through the circuit. I am shorting this. This is 400 milliamps. Now I will show you an example with this LED strip. Now if I connect the LED directly to the power supply, it will draw around 600 milliamperes. But if I want to adjust the current or limit the current, I can use this circuit here. I limit the current of this circuit to 400 milliamps, and now I am driving the LED strip using this circuit, and you can see in the ammeter it is showing 400 milliamps. So I can easily control the current of this LED strip. If you learned something from this video, then make sure you hit the like button and subscribe to my channel, and also press the bell icon. And if you haven't watched the previous video of my channel, then make sure you watch the previous video on DF Player Mini. And the most important thing, be creative.